Hi, and welcome to this Now Maths video on how to use Pythagoras Theorem. Firstly, we need to know what Pythagoras Theorem is. And to use Pythagoras Theorem, we need to know about a side called the hypotenuse. The hypotenuse is the side opposite the right angle in a right-angled triangle. And the special property that the hypotenuse has is that it's always the longest side of a right-angled triangle. When using Pythagoras Theorem, we always label the hypotenuse with the letter C. So if we take a look at the triangle on the left-hand side, we can see that the hypotenuse would be opposite the right angle, and we label this with the letter C. We label the other two sides with the letters A and B, and it doesn't matter which order we label these other two sides. Similarly, if we look at the triangle in the middle, we label the side opposite the right angle with the letter C, because this is the hypotenuse, and again we label the other two sides with the letters A and B, and similar to previously, it doesn't matter which order we label the other two sides in. And finally, for the triangle on the right hand side, we label the side opposite the right angle with the letter C, because this is the hypotenuse, and we label the other two sides A and B in any order. Now, if we label any right-angled triangle in this way, Pythagoras' theorem tells us that a squared add b squared equals c squared. This tells us that if we square the lengths of the two shorter sides and add them together, the result is equal to squaring the hypotenuse, or the longest side. In this video, we're going to take a look at how to use Pythagoras' theorem to find the missing length in any right-angled triangle. Now let's take a look at an example. So in this question, we're given a right-angled triangle with two sides and we're asked to find the missing length x. In order to use Pythagoras' theorem, we need to label the sides A, B and C in the way that we just have. So to begin with, for this triangle, we label the side opposite the right angle with the letter C, because this is the hypotenuse, and then we label the other two sides A and B in either order. We then write out Pythagoras' theorem, which is that a squared add b squared equals c squared. And what we're then going to do is we're going to pick up our values of a, b and c from the diagram, and we're going to substitute them into Pythagoras' theorem. So for us, a squared is going to be 3 squared, because our a is 3. Then b squared is going to be 4 squared, because our b is 4. And then c squared is going to be x squared. We now have an equation, and we're going to try and simplify this equation a little bit. So looking at the 3 squared, we can write 3 squared as 9, because 3 multiplied by 3 is 9. Then 4 squared is 16, because 4 multiplied by 4 is 16. And x squared for now we'll just leave as x squared. Now if we add together the two values on the left hand side, 9 add 16 is 25, so we end up with 25 equals x squared. We're trying to work out the missing length x, and the opposite of squaring something is square rooting. So if we square root each side, on the left we'll end up with 5 or 5 centimetres, and on the right we'll end up with x. So the missing length x must be 5 centimetres in this case. Now let's take a look at another example. So this time we're given a right-angled triangle and we're asked to find the missing length x again, except this time we're asked to find the missing length to 3 significant figures. So for the last question, our answer came out as a whole number or an integer. This time we're potentially expecting our answer to come out as a decimal, given that we're asked to round the answer. So again, we approach this in the same way as previously. We label the sides A, B and C first. So the hypotenuse is the side opposite the right angle, which will be the side with the x on it. And then A and B are the other two sides, which we can label in whichever order we like. We then write down Pythagoras' theorem, which is that a squared add b squared equals c squared. And then we substitute our values of a, b and c from the diagram into Pythagoras' theorem. So starting off with a squared, for us, a squared is going to be 9 squared, then b squared, which for us is going to be 5 squared, and then c squared, which for us is going to be x squared. We then simplify this a little bit, so looking at 9 squared first, 9 multiplied by 9 is 81. Then looking at 5 squared, 5 multiplied by 5 is 25. And then the x squared can just stay as x squared for now on the right hand side. Now if we tidy up the left hand side, we can do 81 add 25, which is 106. And the right hand side can stay as x squared again. And then the opposite of squaring is square rooting. So if we want to obtain x rather than x squared, we square root both sides. And when we square root the left hand side, this time we're going to get a decimal, which is going to be 10.29563 and so on. And on the right, we'll end up just with x. And given that we're asked in the question to round this to 3 significant figures, we look at the first 3 digits of the number and we round the last of the 3. So we're going to look at the 2, and after the 2 is a 9, which tells us to round this to 10.3 to 3 significant figures. So our missing length x is 10.3 centimetres. Now let's take a look at a third example. So in this question we're given another right-angled triangle, and again we're asked to find the missing length x to 3 significant figures. The first thing we need to do is label our sides A, B and C. So C is the hypotenuse, which is opposite the right angle. So in this case C is going to be 11 centimetres. We then label the other 2 sides A and B in whichever order we like. So I'm going to label X A and 6 centimetres B. This time you'll notice that C is 11 centimetres rather than the missing length x. We're still going to approach this in the same way though, so we'll write down Pythagoras Theorem, which is that a squared plus b squared equals c squared, and we're going to pick up our values of a, b and c and substitute them into Pythagoras Theorem. So for us this time, a squared is going to be x squared, then b squared is going to be 6 squared, and then c squared is going to be 11 squared. Similar to previously, we can do a little bit of tidying up here because we can square the 6 and the 11. So the x squared we will leave as x squared. Then 6 squared is 6 multiplied by 6, which is 36. And on the right hand side, 11 squared is 11 multiplied by 11, which is 121. Now we have an equation where we have x squared add 36 equals 121. If we want to work out the missing value x, we're going to try and get x on its own in this equation. So to do this, we're going to have a look at the add 36 on the left hand side, and we're going to do the inverse of adding 36, which is subtracting 36. And if we subtract 36 from the left hand side, we get x squared. And if we subtract 36 from the right hand side, 121 subtract 36 is 85. We now have x squared equals 85. So to work out x, we need to square root both sides. And the square root of x squared is x. And the square root of 85 is going to give us 9.29544 and so on. We're asked to give our answer to 3 significant figures. So we take a look at the first 3 digits of our decimal, and then we're going to round after the 9. After the 9 is a 5, which tells us to round up. So we're going to round this to 9.30 centimetres. So our missing length x is 9.30 centimetres to 3 significant figures. Now we're going to take a look at one final example. So again, we're given a triangle, which this time is on a slight angle, and we're asked to find the missing length x, giving our answer to 3 significant figures. So we approach this in the same way as what we have the previous questions. We label our sides A, B and C, starting off with the hypotenuse, which is the side opposite the right angle, which in this case is 13 centimetres. So 13 centimetres is C. And then A and B we can label in either order. So in this case I'm going to label the 7 centimetres A and the X B. And it doesn't matter which order you do this in. We then write down Pythagoras Theorem, which is that A squared add B squared equals C squared. And we will substitute our values of A, B and C into Pythagoras Theorem. So for us, A squared is going to be 7 squared. Then B squared is going to be x squared, and c squared is going to be 13 squared. We now simplify this a little bit, So looking at the 7 squared first, 7 multiplied by 7 is 49. X squared can just stay as x squared. And on the right hand side, 13 squared is 13 multiplied by 13, which is 169. Now we have an equation and we need to get the x on the left hand side on its own. So first of all, we're going to take a look at this 49, which is being added to x squared. And the inverse of adding 49 is subtracting 49. So we subtract 49 from both sides, which on the left hand side gives us x squared. And on the right hand side, 169 subtract 49 is 120. So we have x squared equals 120. And to work out what x is, we need to square root both sides. And the square root of x squared is x. And then the square root of 120 is going to give us 10.95445 and so on. Again, we need to round to 3 significant figures, so let's take a look at the first 3 digits. We round after the 9. After the 9 is a 5, which tells us to round up, so this decimal rounds up to 11.0 centimetres. So our missing length x is 11.0 centimetres to 3 significant figures. Thank you so much for watching this Now Maths video on how to use Pythagoras Theorem. If you found this helpful, please give this video a like and subscribe to the Now Maths channel for more help with your maths. See you again next time.